So this is going to be our second problem on specific heat. This one, a sample of aluminum releases 55.0 kilojoules of heat. So again, heat, that's going to be Q. As is cooled from 94.6 degrees Celsius to 22.8. So in this case, we heat it up to 94.6 and we maybe dump it in some cool water to cool it down. And we're saying, what is the mass of aluminum? So whenever you cool something down, it gives off heat. So that's an exothermic reaction. So again, I got my specific heat equation. I like to write down what is given. The specific heat aluminum, you can look that up. So it's actually 0.902 joules per grams degrees Celsius. Q is going to be heat released. In this case, it's 55 kilojoules. So I'm going to give it a negative sign. So whenever you release heat, you give it a negative sign. So negative 55.0 kilojoules. One thing about it, this is kilojoules, that's joules. I'm going to go ahead and just convert that to joules. So 1 kilojoule is 1,000 joules. So 55,000 joules with that. One thing about that, you don't have to write down a negative if you don't want to for these problems, but you know it's always kind of a good habit to do that. The mass, that's what we're looking for. So it says, what is the mass? So again, one of these is going to be unknown. Change in temperature, well, my initial was 94.6. We cool it down to 22.8. So that's my T final. So 22.8 degrees Celsius minus 94.6. And this will give us a negative 71.8. Notice that this is going to cancel out that negative up top. So they'll cancel out. So what we're going to do now is solve for M. We have the equation. We're going to solve for mass. The quick way to do that is I'm going to cross multiply. So I'm just going to cross multiply. That's equal to Q. And then I'm going to bring specific heat and change in temperature over as a denominator. So let's go ahead and just plug everything in. So our Q now is 55,000 joules. Again, I like to write down the units to make sure everything cancels out. I should be left with grams. Our specific heat, 0.902 joules per grams degrees Celsius. And our change in temperature is 71.8 degrees Celsius. Our degrees Celsius cancel out. Our joules cancel out. When I do this division, the grams are going to flip up on top. And I'm going to end up with 849 grams. So again, a couple things. Always write down what you're given. In this case, I had to solve for mass. So you had to do a tiny bit of algebra. Always make sure that your Q is in joules. One thing about that, I didn't write the negatives in there, but if I did, the negatives would have canceled out. So again, you can write it. You don't have to write it. It just depends on you. So I'm going to end up with a mass of 849 grams.